All right, welcome back to another stream of OS Dev gardening. Um, this is gonna be a good one, I think. Again, we're working on the build system. That's what we've been working on for a couple streams now, and I'll just be honest, I'm not totally sure how much longer I want to spend on doing this, because it is interesting work and it does feel necessary, but just after a while, it doesn't feel super satisfying in some ways also. But we have been making a good amount of progress. Um, this is what the repo looks like now. So we've moved a lot of files into this kern directory. Yeah, like a lot of these kernel source files and header files. But there are still some bugs because we've been doing this. Yeah. I feel like I should start writing these down somewhere. Maybe just directly into here. So one obvious bug is that the kernel memfs is still present after a clean. The files are, I guess, the .d, we have these .d files. Hello, clean? Okay. Okay, yeah, so we actually do go out of our way to remove the .d files and stuff, but that's super error prone. And I don't actually know why this kernel memfs thing is still kernel memfs thing is still there. Make kernel. What if we just make? Oh, oops. Make. Okay, so this should have done it. We have a bunch of stuff now. Kern. And okay, I don't even see a kernel memfs. Because I didn't run make kernel memfs. Kernel memfs. So that should have done it. And it seems like we do have one here. Let's look in kern. I don't even see. Okay, so that must have been a fluke. So I'm going to get rid of this card actually. That's kind of weird. So yeah, but just for some commentary, one reason I'm getting a little bit, I would say, I don't know, discouraged or maybe a bit nervous about just all this makefile stuff is, where'd my VSCode go? Oops. Where did that go? Okay, here it is. Is that we're writing the build system in just plain makefile, which actually requires a lot of work. Make does some stuff for you, but it does not give you a lot of other stuff, and you need to do a lot of things yourself, it seems like. And one big example is this include -d thing. I think that's also a bug because right now we're only including the d files in the current in the root directory, but we're kind of ignoring all of the .d files in the kernel directory now, which I think is super not good. And so there's all these opportunities for bugs and mistakes in the build system, which is just a very annoying place for them. It feels just stupid to be spending so much time debugging the build system. That's not the place we should be spending our engineering resources. So that's kind of why I'm getting a little bit discouraged with just doing all this makefile stuff. And the obvious thing to maybe consider is porting everything to CMake, which is a more modern build system and it operates at a higher level. One analogy is that when you're writing a make file, well, yeah, makefiles are quite low level. CMake is a layer on top that provides you a lot more stuff. CMake takes care of all of this dependency stuff. CMake takes care of doing out of source tree builds, because right now our build is directly inside the source tree, which is annoying and messy and just leads to all these files everywhere. So ideally, we want to have a build directory that contains all of the object files and all of the build outputs, but that's totally separate from the source tree. So yeah, anyway, that's just a bit of background, but porting to CMake is also going to be a huge project. That's my assumption. Porting to CMake is going to be a big project. And one thing that's just intimidating is that I still don't totally understand the build system that well. Although maybe it's not even that bad. I think there's a lot of junk in here that makes this way harder to understand than it needs to be. And maybe it would all be way less intimidating if we got rid of it and then we're able to see like how small this thing could be actually. So maybe that's a worthwhile exercise. You know, there's all this box stuff that I like kept around because I was kind of not sure, but I think we need to be a bit more aggressive with it. Yeah, we can always get this stuff back. There's all this kind of complicated stuff about generating a GDB port and whatever, which just seems so complicated. And we'd generate GDB init dynamically, and yeah. So I don't even know what this extra thing is doing. So there's still a lot of complexity here. Make requires you to do these arcane things for some reason, like this .precious thing. And I don't know if I particularly want to become an expert in like make files and stuff. There's a lot of stuff I don't know about them. And the fact that I don't know them is probably hindering my ability to do this refactor to some extent. But yeah, maybe. So, but those are just some general thoughts. We are accumulating tech debt already with this kind of shared compile infrastructure between the kernel and user space. And there's like these shared headers, which are kind of strange. But yeah. Yeah, okay, let's just take a step back though. Let's just take a step back. This is our code base, and one thing that's just so annoying is the fact that it's not an out of tree build. I want to do that so badly. Should we just do that? I mean, we have a few options. Option one, we work on the out of tree build today. That would make me so happy to do that. And I don't even know if it would be that hard. That would make me incredibly happy. The other thing we can do is continue to try to move user space files into its own directory and keep cleaning up this and adding directories. If we are just purely, maybe we go back to some core principles. Have fun the entire time, keep moving forward. I mean, for me, the thing that would bring me the most joy is to work on the out of tree build. That's just what I just want to work on that. And so, yeah, maybe let's just do that. So I don't know if I feel like I must have that tracked somewhere. Out of tree build. Maybe we promote this into in progress. Get user space building. This was from last time. or maybe I think maybe a couple streams ago, because in the process of making this kerner, we broke we I think we just totally broke the build. But I think that's just totally not true anymore. Like the build works completely, and we are up and running. So we can call that done. Get user space building. I think we did that in maybe one of the last two ones. We're tracking our tech debt, out of tree build. Yeah, just for an overview of what I've scheduled in here, I've been writing my ideas down, and one thing I'd like to do is just have, one thing that excites me is just getting kind of professional build infrastructure set up, which maybe means maybe I'm more destined to be like a build engineer or something like that in my life if I'm so excited by these topics. But I like the idea of just having a really, professional project with debug and release build infrastructure, and an out of tree build, and maybe we can do that thing where we build in like the git hash info into the project so that like at runtime you can like do a version check and see which like hash of the code base the kernel was built from. For some reason that excites me, and so that's just a couple other things that I jotted down. One thing of urgency as I'm seeing this clang-format is we need to this is more like a dev infrastructure, like dev environment thing, is auto clang-format on save. That's actually huge. I think that shouldn't even be that hard, and that's quite high priority, because in the current state of things I am so likely to regress on the clang formatting. I might have even done it already. I don't even know. Clang format. Let's just do a check. And the way I can check for this is, I think, just real quick, what if I do this? Fish shell supports this thing where you can do */ and this will find all of the C files recursively. And then I can do the same thing with H. And it seems like we actually only have a single header file in the root directory. So what I'm going to do is make use of that. And let's see, did anything? Okay, nothing changed. But let's just do a quick test. Let's just do a quick test. For example, I'm going to add some spaces here, and my editor is not configured to auto clang format on save, so it's not going to format that. And then now let's run this again, and we can see that clang format did something. So that's good. So that means we haven't regressed on that, but let's just do that right now. I am going to look for the clang-format VSCode extension, which I think does, which like I've used to do this in the past. And let's see. Okay, so we've installed that extension. That was pretty easy. It's not configured on save. Format document. Multiple format. Configure. Clang format. Oh no. Wait, what happened? Also, what? Wait, whoa. Something is, okay, maybe this is, so it shouldn't have changed so much. It should not have changed. And also now I'm realizing that. I actually don't want this formatting. Really, I don't want actually the formatting with this thing on the same line. But okay. Just to be really sure, I do have a .clang format file right here, right? Yeah, I do. And I don't know if I need to make it pick it up or something like that. Fallback style. Okay, I think this is what I want though. I think file is what I want. So what's all this stuff at the... I feel like it changed way too much. I think it even used clang format fallback style. What if I change this to file? Oh, what? Why did what what's going on? What just happened? Why did that open? Man, okay. I thought this would be way easier. None of these... Oh, huh. Left empty to use clang format dot style. If I search for clang format dot style, do I... Yeah, so I don't actually get it. Because if we're using file here, that means clang format should be trying to find... should be finding this thing. So maybe, yeah, maybe I need to... I'll put it... okay. Format document, clang format. Invalid fallback style file. So that's the thing I just changed, right? But what's up with this weird... Okay, okay, this is invalid then. Okay, let's try one more time. Why is it not printing anything out? It's also not doing the formatting. So this is kind of hard. I feel like, yeah, I feel like this is kind of hard to debug then. It's C++, yeah. Which version of clang format do I have? Do I have my version too old? 1706, no, I think it's pretty new. 3.8, I have no idea. Shift. Clang format executable. Some examples. Bang clang format. Mm-mm. So it's interesting that it's just not. Maybe I have to maybe I reload. Maybe that does something. Format document. No, index fallback style. Invalid fallback style. That means it's trying to use a fallback. Is that right? Hmm. Clang-format is the default. Cannot format due to syntax errors. What happens if I run it on the command line? Yeah, it does that, right? But what's happening? Wait, okay, am I doing something very dumb right now? Oops. This is saying it claims to have. What is? Oh wait, okay, wait. So this diff is just showing that the file has been changed. Oh, and okay, I didn't run it on CPP files. Oh, interesting. I see the problem. When I clang formatted the whole thing last time, I forgot to run it. I never ran it on CPP files, and I just happened to open the one CPP file we have in this thing. So that's why the style was messed up in the first place. Okay, so I'm just going to do cleanup commit, cleanup, fix stat for test CPP. Forgot to let's go to a more reasonable file. Like, is this a more reasonable? I just want like a small boot main.c. I don't know. Doesn't really matter. So let's say I do something kind of odd like this. Okay, right? Format document with. Can't format. Due to syntax errors. But okay, and then this thing updated because we made a change. Syntax errors. Is there any way I can see the command line? I don't want this right now. So I think this is probably what it means by can be file, right? File, workspace, user. Let's get rid of some of this stuff. Okay. What if I... No, I can't even... Man, that's kind of weird. Okay. Well, yeah, I don't want to get too bogged down in this whole thing. I thought this would be a lot easier. Let's just disable this. Maybe I should just be using the plain C++, this thing, right? Maybe I'm being silly and overcomplicating things. Okay, maybe I am. Maybe I should just do that. Okay, so that seemed to fix it. All right, format on save. Let's just, all right, so, okay, so let's pretend we're doing some coding and I'm being super sloppy, right? I'm just like being very weird. Save. That didn't format it. Format on save. Also, why is this thing still running? Didn't I disable it? What if we reload the workspace? Save, right? For the C language, sure. I thought I already had this actually. But if I do format document, configure this. Okay, I think it just got like out of date. Int x save. Okay, this is exactly what I want. Apparently that's valid, but yeah, this is exactly what I want. Now I can be free, and it'll reorder my includes and make them alphabetical. The spacing's all good. I do this, it'll do this, and x, it'll do this. Okay. Yeah, maybe I think I'm just being a bit too smart. I've used that that clang-format thing in the past, that like extension, but you know what? But so let's not worry about that and move on. So that's good. That also immediately just feels good to do. So this was the first episode. This is right here now in the, I think we're in the 5th one, or maybe even the 6th one. Kind of did this also, so yeah, feels good to auto playing format on save. That's a necessary quality of life thing. And that's also a reason to not use Vim anymore so much for editing text, because I don't have that configured for this. So, yep. All good. Let's get back to the main task now. I just realized I don't have my timeout thing running, so let's just go ahead and take a quick 20-second break. Be right back. Okay, let's get back to this. So we have a lot of work we can do on this make file. It's still not super clean, but we are getting somewhere. So I don't know. One thing I'll just do. Also, I don't. VS Code offered this Makefile extension pack. You know, why not? Provide Makefile support in VS Code. Makefile creator. What does this do? From Makefile to debug. I don't really care about running the build from VS Code, but is that all it does? Mostly just like, but it already does have the syntax highlighting and stuff. This I'm just getting distracted by all this noise. Whatever. And for the correct chemo. I don't know if I'm relying on these things or not right now. So anyway, let's stay focused. So let's make, I wonder, does renaming work here? Refactor, no factorings. Yeah, it would be cool if I could refactor Makefiles with VS Code and like rename variables. One thing maybe I'll just do quickly is kernel dir is so verbose and takes up a lot of room. I don't love it. So I kind of want to just kernel dir. I should really learn this. I'm just gonna do kdir. Is this the one? Across one file. Yeah, let's just do that. Nice and easy. Make clean. Make kimu. A nice little harmless rename. Git history wise, where does this go? I think it goes directly into make. That's where we introduced it, so that's where it would go, I believe. And at risk of things, let's just try amending it. Oops, amend view conflicts. All right, maybe never mind. We are getting slightly bogged down in that kind of stuff, so I'm not going to focus too much on that for right now. Now we can do build, and what? So I'm going to assume the builder maybe has not already been created. So let's see, how does this even work? These are all the flags. These are these really final build targets for the end output. I mean, one thing that would make this file a lot more easy to deal with if it were broken into a couple make files that each had their own responsibilities. Like the user space stuff is separate from the kernel stuff and whatnot. But let's just really focus on this. So key target is here. Kernel objects, entry other. So the way this currently works is we simply ask it to make, we tell the kernel target that we need all these objects, like correspond to these C files. And then it just does it. And then it can link them all and produce the kernel. So step one, like there's maybe a few ways to do this. The simplest way is to keep things really the same and then just start prefixing things again, kind of like crazy. So we can what the build directory should kind of look like is it should kind of replicate the directory structure of our source code repo with the current directory, but then instead of C files and stuff, it's going to have like .o files. Yeah, and I'm also going to try to not look at other projects. Maybe at some point I will do that, just if I get too stuck with this. But yeah, I also have a little bit of a fear that I just simply do not know enough about like Make to do this well. I'm aware that you can get it to like cause Make to like CD into a directory before it starts doing things. And maybe that's kind of what we need, but the fact that we're using an implicit build rule is kind of making this hard. What we want to do is we want to compile these object files and have the output go into a different place than the source file. Yeah, and I don't exactly know really the best way to do this. Maybe I'm going to actually just ask ChatGPT real quick. Yeah, I think this is fair. I think I will slightly tap out a bit. What is the best way to implement what is a simple way to implement out of tree build with GNU Make? Oh, run. Okay. Define variables for source directories or define headers. When defining targets, use the variables to refer. Supports out of tree builds. Flags. Okay. That's kind of weird. That's using -i with the source dir. Sources. Objects. Target executable. Okay, maybe this is helpful. Maybe we can use this as reference. So builder, source dir, object dir, and we say we want an app, and it's going to be really in the builder. And that's what the default target's going to make. In order to make this, we're going to need all our objects. And here, they've done this transformation. Interesting. Yep. And then they, yeah, do the compile. And to create, what is this? Compile. So this, the kind of thing I don't love doing is manually specifying these compile command lines. But I think we can take reference from this. Yeah, I think this is a good starting point. Okay. Objectdir. And in our case, again, okay, let's just focus on now I'm kind of regretting yeah, these like super terse things. You know what, maybe I will actually just revert that real quick. Just drop this commit. Okay. Oh, really? Okay. There's conflict in the dropping of this. What I want is, let's just go back here. Okay. Builder, build, right. Yeah, in our case, let's just again stay focused on and just approach this step by step with just making the kernel thing. Like, yeah, there's other things. There's this other stuff. Okay. The things we need to care about are like this thing, the boot block, entry other, interesting. Okay, the kernel depends on all the kernel objects and the entry other and the init code and this kernel LD file. So this happens first. And then once the kernel, then the objects are compiled, and once the kernel is there, then the kernel is used. And so the boot block then is also kind of in parallel created and signed. Interesting. That is really this bootloader thing, I think. It's like this minimal bootloader that jumps, yeah. This is what, yeah. Along with what you call, so bootasm runs really first. Bootasm bootstraps into boot main, which jumps into C. Boot main loads the kernel from disk and jumps to it. So boot block is, yeah, it's like the bootloader kind of stuff. And then all that happens is we assemble a disk image. We create a blank file that's like big, and then the input. Okay, I don't get, it seems like we then just kind of like overwrite the file with the boot block, but I don't know it, not no trunk. Does that mean there's a bunch of empty zeros at the start? That seems a little bit weird. And then then we basically kind of append the kernel into this file at seek1 is not 1 byte, but 1 block, I think. And by default, DD uses 512, a 512 block size. And the boot block needs to be exactly 512 bytes, I believe. I think that's correct, although I would be interested to see how this is all put together. It compiles both of these things. Then it links them into bootblock.o. Then it obj copies with the binary mode something into bootblock. Anyway, yeah. Anyway, so yeah, again, it would have maybe been simpler to try to do this before we made this kernel directory. Because now I'm kind of getting caught up in how I want my build directory to have a mirror image structure of the source file directory, which I don't completely know how to do. Yeah, but let's just come back to the ChatGPT real quick. Okay, so what we need to do, yeah. So to start off, we have our build dir, our kernel dir. I mean, yeah, to start off, we're just going to object dir. So sources. Yeah, we don't even have a sources list though. We only have a list of objects. And I think, yeah. Okay, so when we run make, we're gonna let me just do one thing just for development. Just for development, make clean. Okay. I just want to build the kernel. That's all I want to do. And I think that's all. Wait, no. Make all. Kernel, init code, boot, entry other, boot, block other. The kernel is not related to the boot block. So I don't actually know. Make clean, make kernel. What happens then? Oh, 20-second break. For some reason, boot block other. Oh, what? It's created by entry other. Okay, anyway. So just to okay, so one thing, let's just start copying this. So object dir, and it's this object dir within the build dir. So what if, so I think this is really an important part now. We're going to need, I'm just maybe going to hand roll this a little bit. So we have, just for starters, what's the smallest step we could take forward? Let's move the kernel objects out of the source tree into the builder. All right, I'm just gonna do this real. So, builder, make dir p at, right, make clean. You make, and then who depends on the object dir? Or is that, oh, is that what this thing is? I don't, make file pipe in depths. Normal prereqs and order only. Occasionally, you might want to ensure that a prereq is built before a target without forcing. Interesting. So that's real. Okay. So yeah. Kernel dir. And what I kind of want to do is I want to build a version of this list that has the builder prefixed, but I don't know. Make file. How to prefix a list with a variable. Okay. The add prefix. So what if I do, just to keep this really controlled, I'm going to make a new list called build build obs equals add prefix object dir. Okay. Okay, oops. Build dir obs. I think now we need a slash here. Maybe we'll just do that. Also just for consistency. Although, maybe not. A lot of every use here actually has the slash after it. But in this case, okay, whatever. So now we have our build objects. And so now it's like, I just really want to collapse this and this and get rid of all this like noise, basically, right? So we have, oops, build objects. These are the things that we want. The corresponding, for every build object, it's going to correspond to a k kernel dir blah dot c, and we also need we need the builder to be created, and we also need the kernel object dir. Okay, I think we're slowly getting somewhere, but also this is just a bit of an exercise in pain also, because CMake would do all of this, I think. So we are almost doing the equivalent of like coding our build system in assembly or something like that at such a low level. What ideally would happen is it would automatically replicate the directory structure, but I think I'm getting a little bit caught up in that idea, which is making things harder. So, and I'm just for development, I'm going to make kernel object, or I'm just going to make k objects, which is just so I can like run this easily. Build. Just saying I just want a target that's going to try to make all the build objects. In order to do that, I need all of these source files. No, but this is not right. Yeah. I kind of, I want to find a way to, basically what I want to do is I want to put a star here, like for any of all these object files I want to make with this path, and in order to make anything like that, I'm going to navigate to the equivalent path in the source tree. I'm just going to ask GPT. If I have a make build target, like, can I use an asterisk? As a while. This is such a bad question, a poorly formed question, but what does it say? Pattern rule, like, as a wild card. So yeah, any string of characters is used to define how to. Okay, maybe I just need to be. Okay, so what if we want to make an object file in the builder, how make interprets. What if is this possible? I don't know. Pattern rules. Yeah, here I'm really getting off of like the beaten path of my knowledge. Maybe I should just ask ChatGPT very directly what I want to do. I want to make a makefile that does out of tree builds. Right now I have .c files in my project root_dir and also in a kern_dir. I want my build, my out of tree build_dir to replicate this source tree directory structure, but have object files instead of C files. How can I do this? Do I need to press Command Enter? Okay, I think ChatGPT changed that. Okay. Let's see. And now it's proposing this thing where it's like find all of the files, which maybe is a reasonable idea, although I kind of am used to explicitly defining them. Is this, okay, is this what you need though? Huh. Yeah, just a builder. Okay, so I think I was on a somewhat correct path of thinking. This is interesting. Okay, just copy it. Builder. I don't know if this is right though. Builder something.o. Then it's just that some, and then maybe the entire path is expanded here, and then I don't know. It's like makedir-p. Maybe it's like this thing, but without the file, maybe. And then the C flags. Hopefully that's all that's necessary. But in our kern, we also have assembly files. So maybe I need the same. So now I basically need to make implicit versions of all these explicit versions of all these input build rules. I'm just gonna search Google like make file implicit build rule C object. Using implicit rules. Catalog of implicit of built-in rules. Huh, okay. So this is the definition of what happens, because I want to make sure when I'm defining my own ones that I'm not accidentally losing something. It's interesting that it passes both the CPP flags and the C flags when compiling a... Is that what? That confuses me for some... Oh, CPP... Sheesh. CPP stands for C preprocessor, not C++. Good Lord. Okay. That's why. And we don't define any CPP rules here, but we could. And that's what I'm talking about. If we hadn't looked this up, I wouldn't have known that maybe CPP... Anyway, what is... Yeah. Okay. Okay, this is interesting. This is interesting. This is also kind of inefficient because it's now it is running makedir.p on every single object file build, which maybe is not that many, but it seems a little bit wasteful. The more efficient thing to do is like a first stage or something where you kind of map out the directory structure in some kind of way, pre-populate all those directories, and then you don't have to do this on every single object file build. But anyway, so this is already quite interesting. So here they have their sources for each dir and source dirs, right. Get all the sources and then map that into the object files. Yeah. Map that into the object files. Okay, good. We have a similar thing. We don't declare the sources at all. Maybe we could. That's kind of more consistent with this modern CMake style approach where you declare in your build system, you declare all the C files and stuff that you have. Here we're kind of going a step further and declaring all the object files we need. But yeah. Anyway, so what happens if we just do this? Because now we have our build objects thing. Objects. Yeah, so that's exactly. So this is taking all those C files and doing a transformation where it prepends the builder and then changes the ending to .o, which kind of, that's like a, yeah, that's, I think I like that a little bit better. It solves this weird problem with the slash thing. So I think that transformation is kind of powerful. So, okay. And so this is going to be, okay, so this needs to totally change. It's like, it's objects. Oh. Yeah, how do I also print something out? I want to kind of like, yeah, debug this a little bit. How to print out makefile variable, then abort build. Oh, it's 1 second break. Okay. So what do I do? What if I just do make? Okay, nice. So that looks correct to me. That looks correct to me. Yeah, okay. So we've added this thing. So now we've expressed that we want all these build object paths. And I'm going to run this. And then now, in order to satisfy that, it's going to use this rule. And I'm just going to cross my fingers, make clean, make k objects, please. 145. Is it the tab thing? It's the tab thing. Okay, yeah, you need to use tabs with makefiles. Please. Okay. So now that failed because we don't have a build rule for assembly. And if we look up our assembly, okay. AS flags. Interesting, the lowercase s and the capital S are different. And actually, we need this one. I'm just gonna save this link to Miro, because that's a useful one. Okay. So oh, interesting. Really? CPP? Oh, wow, what the hell? So in our case, we have a capital S. There's entry, I think it's entry.s, which uses includes, so it needs the C preprocessor. So we need to call I wonder, I think it's something like this. It's kind of annoying because I don't. So this thing corresponds to this part, and this thing corresponds to that part. Again, this is such a low level use of the build tools, which is like kind of annoying, but yeah, I'm just gonna lean hard on ChatGPT. How to use CPP, C preprocessor CPP to convert .s file to .s file. I just need to know the invocation to use here. Output, input, okay. So something like this. Exercise in pain, okay. And then now we want to generate an O file from a .lowercase s file, which means we need the, yeah, so now we're like hand rolling our own explicit versions of all these implicit rules. AS and AS flags. And the thing they don't tell you here is actually the concrete invocation, but I can find that out by going to my second checkout and looking, looking at all the command lines. Which, that is just interesting. Tree.o, the only mention, what? Oh, here we go. So this is clearly it being used. In order to build this, for some, it's calling in GCC though. There's no mention of gas anywhere, used anywhere here, which is very odd. I'm going to just copy what the original build is doing. So in order to produce, this is so interesting though. Oh, I see. It skips the preprocessor manual step by just directly using the C compiler, which knows how to do stuff. So it's doing CPP flags. No, yes. Or it's doing AS flags specifically. And I wonder like why. Makefile. .s, is there some custom rule that was pre-existing? Is it no? Nope. Okay, I was maybe thinking that there was a pre-existing entry.other compilation rule that was doing this custom stuff that seemed to deviate from our makefile reference thing here, wherever it went. Yeah, this thing. Yeah, but I don't see it. So anyway, let's keep it moving. I think we're definitely getting somewhere. So so here we were just passing the compiler the AS flags. Yes, okay. Cool, let's go back. Make clean, make kobs. Ugh. Cannot find CRT0. So what? Am I doing something wrong? Okay, I think I missed the -C here. Right, I missed the -C. What is, so specifically, the C was coming without anything after it, then the -O, then the thing finally. In this version, it is the same. But that was in the old build. Let's just, let's just stick to the old build. Oops. Yeah. Make clean, make kobs. Okay. Wow, did that kind of work? Build. Kern, nice. Oh man, wow, what a What a journey. That feels cool, though. So just now yeah. How to make file look for .d files in build recursively in builder, because I think that's important. Because again, we need to do all this super low level stuff like managing our own .d files and stuff. But just for starters, I am quite proud of myself for getting that far. That was a bit hairy, a bit sketchy. But we're well on our way to having a kind of inefficient build. Yeah. I wonder. Yeah, it's kind of annoying that this line is duplicated all these times. What did ChatGPT say? ChatGPT was saying... ChatGPT made this... Oh. Okay. Earlier, ChatGPT had this single thing for making it once. Anyway. Okay. Anyway. So now that works, build objects, we are maybe kind of close, because then if we just say build objects here, what happens? Okay, then something clearly. So kernel, we want, it's not just kernel anymore. Yeah, it's like we can clean this all up later. Let's just keep it moving. Build dir/kernel. That's what we want. And over here, we should just say this. And for the moment, and it's still okay. Okay, oops. Okay. Okay. Wow. So we replaced all of the references to kernel with this variable corresponding to our thing. We're still building the rest of the stuff in the root, but that's fine. Make clean. Make. Oh, dang. But now, now I can't directly say make kernel anymore. So all these internal reference. So I think it's time to make a variable. So call this kernel. I don't know. And it's going to be called builder kernel for the moment. Okay. I don't know my VSCode well enough. I want to like roll that back. Oh, okay. That's kind of embarrassing. Is it? Oops. Oh, oops. Okay. Okay, let's just keep going. So for these three, I'm just going to do kernel. So now we're all using this thing, and then over here we can say, yeah. What's the fastest way in Vim? C. Oops, nope, wrong one. C. Oh, it's the other one. Jesus. Kernel. Okay, to build the kernel, we need all the build objects. This naming is kind of bad. Make clean. Make all. Okay. But this thing is all messed up. Because, yeah, now it's build objects. Make clean. And in our make clean, we need to remove rf builder, which should be fine. Clean. Make all. Whoa, okay. Oh, this is, streaming is fun, but it's a little bit stressful, but I'm glad this is kind of working. Nice, check that out. Look at us. Look at us. This is worth a temporary commit. Although now we're doing this kind of weird thing. This feature is unrelated to, it's kind of unrelated to the add ders branch, to be honest. So if I really had the most absolute rigor, I would have actually started this work, I think, maybe on the main branch. But now I'm like mixing my approaches and stuff, but yeah. So in this case, I'm going to relax this principle of like trying to do things in a really like super clean way. And I'm going to prioritize having fun and moving forward beyond that. So I'm not going to care too much about it. So I'm just going to add like temp, or maybe whip initial out of tree build. Good. Because we got the kernel building out of tree, and it might not even be that hard to get everything else building out of tree. We checked in all this garbage. We'll probably squash just a lot of this stuff later. We don't need the k-objects thing anymore, really. This naming is all awful. We'll clean that all up later. But yeah. So let's just take a look though. So what do things look like now? We still have all the boot block other, the entry other, the init code. And so if we can take care of that, then we are doing very good. It's kind of annoying. Okay, kernel. Let's just do that. It's kind of annoying that we can't, because it was very easy and nice to specify just these names of things anymore. But if we're adding the builder in front of everything, it just, yeah, it's just much nicer to have this label with no variable anything like that. Or maybe not. My instinct was to kind of make an alias, like a make alias. But also what we've kind of accidentally done is we no longer have the ability to just run these targets independently from the command line anymore, because now it's all this like build. The build thing is prefixed. So there is some value in retaining these target aliases for that purpose. Okay. We will clean this all up later, but oh, Is it really already? Wow. 20-second break. Actually, I just decided during that break that I think we're going to cut the recording here. It's already been an hour and a half, and we'll just do this stuff next time. So, as always, thank you for watching, and I'll see you next time. Peace.